Hi all, good morning. Kindly confirm the audio. If I'm audible, kindly confirm the audio. All students, good morning. And you may submit your weather report. Varanasi telling me 32-21. So the temperatures are falling down. Yes. Range is 11 degrees Celsius. Thank you, Sejal, for sharing it. Good morning to all. Humidity is 72%. Good morning, Shravani. Kirti, Abhay, good morning. Aditya, good morning. Sharing from Pune, 3118. Temperature range. Yes, sir, it is audible. Agra air quality is poor, 313. Humidity 72%. Wind 0. The more the wind is missing, the more the air quality will go down. So Meghna is sending us from Jharkhand, 2919, diurnal is 10. Good morning to all. Good morning. I hope I'm visible also. So meeting you after a long break. I hope it was a refreshing break. So Amrit is calling from Mughal Sarai. Okay, daily range is 10, westerly 2 kilometers per hour. Wind is 2 kilometers per hour, southwesterly. Okay, perfect. Temperature, Kodarma is 2 kilometers per hour. Chali. So, thank you for the weather report. And let's talk about the weather report. Say, for example, we're talking about weather report. Weather report. Now, most of you are okay with temperature and temperature range. These two things, I see most of you've got it. That's a good thing. Navi Mumbai, precipitation 0, wind is 16. That's amazing. Banaras, the wind is 8 kilometers per hour. So we're writing Varanasi. Varanasi, 8 kilometers per hour. Yes. Humidity 74. So everyone, stop putting in your weather report. Thanks a lot. Thanks a lot for writing that. So let me share something about the weather report, what we would have learnt. Have you seen the temperature? Now the trend everyone, is the temperature falling? Temperature of your city. Has it started falling or not? So first is, has it started falling or not? Maybe gradually. The trend is not on the higher side. The trend is not on the higher side. So Kolkata is 223. Air quality, Agra is 330. Agra is 330. Kolkata is 223. Air quality index. Okay, so everyone. So first trend that you must notice, the temperature is falling down. Second is, you will find that the temperature range with time, temperature ranges will start increasing. Observe that now. In the coming days, observe this. So temperature is okay. Second is, we are looking at wind. Second is, we are looking at wind. And wind, whenever we are talking about the wind speed and the direction. Wind speed and the direction. That all depends on many things. Now, I want to connect it to what is happening around us. Can we do that? Kodarma, humidity 73%, dew point 19 degrees Celsius. Vadodara 36.22, and the daily range. Sagar, thank you for sharing it. Everyone, kindly stop. Everyone, kindly stop. Kusum is saying air quality index 369 in Delhi. So let's come back to this. Let's come back to this, everyone. So first thing, everyone, first thing. So when we are talking about North India, we are connecting it to the current affairs. We are connecting it to current affairs. In North India, there is a lot of pollution. There is a lot of pollution. Pollution can be vehicular pollution. Pollution can be because of the dust construction areas which we are looking at. Pollution can be because of parali burning. Pollution can be because of crackers, whatever is there. There is pollution. Get that? Now for pollution to happen, it's a normal thing in a big city. But when it keeps on happening, it will impact the air quality index. Yes or no? So the air quality index, which is AQI, which is from a index from a scale of 0 to 500. From a scale of 0 to 500, we have Agra going 330, Kolkata 220, and Delhi is 369. Anyone from Northeast India listening to me? Anyone from Northeast India listening to me? Or anyone from, say, for example, Southern India? I'm talking about Kerala, Tamil Nadu. So, what we are talking about is, everyone, please pay attention, that this pollution will happen. Pollution is happening, and because of pollution, air quality is going down. That's a normal thing that will happen. But why is it going down? Why is it going down? Sir, Delhi is facing nowadays a lot of pollution, AQI 500. No, Delhi is not AQI 500. Imagine Assam AQI. Assam AQI is 89. Assam AQI is 89. Imagine, and this is your North Indian plains. North Indian plains. So let's get certain things very clear. We are looking at this thing. Guwahati is 62. So we are all geography student and we are looking at what are the spatial variations. First of all, this is called data. You people have provided us with data. Now comes the question of our analysis. Everyone, please stop. Thank you for that data. You've given that. I'm taking the two extremes. So that's what we are talking about. Ratlam, Madhya Pradesh 69, Indore 189. Big cities, more pollution. Can we see that? Big cities, more pollution. North Indian plain situation, more pollution. Do we get that? When we are looking at Assam, Guwahati, Northeast, first of all, population is low, the vegetation is high, and other things are there. We are going to look at this. Okay, everyone, thank you for contributing. I hope we've started the good debate over here. Jamnagar is on the western side. Jamnagar, Gujarat, air quality index is 130. So this is the coastal location. This is a hilly forested, not Guwahati, if I'm talking about hilly, if not hilly, forested, and like less populated. What are these? These are dense urban clusters. They have vehicles, they have industry, lot of it, and that's what we are talking about. Is everyone okay? So here we are talking about this. So now pollution will happen. First of all, can you compare? Here there are more reasons for pollution, here there are less reasons for pollution. So when we are talking about air quality index, amount of pollutant, and they can be gases, they can be suspended particulate matter. That's one parameter or not? That's one parameter. That if there are more pollutants, then what will happen? Air quality index will go down. But there is a second parameter also. What is the second parameter? Second parameter is dispersal and dilution of pollutant. So first thing we are looking at is amount of pollutants is high in Agra, Kolkata, Delhi. Yes, amount of pollutants released in Guwahati is less. Though Guwahati is not hilly, it's not forested, but less populated. We are looking at that, and the humidity levels and the wind will matter. That's the second part of it. Say for example, Jamnagar. Jamnagar is having proximity to a port called Kandla port. It's also in the proximity of Reliance refinery. So Jamnagar, when we are talking about, it is close to a refinery. So it has industry, it is close to a port, it has transport also, and lot of transport coming to the port. But still its air quality is not as worse, though 130 is not easy, but it is not as worse as Delhi. Why? Can you look at that? Can we look at that reason why it is not there? Jamnagar, almost coastal area, almost coastal area. The second factor is working over here. What is it? Dispersal and dilution of pollutants. The winds are there. Is everyone okay? I also want to tell you, especially people who are living in North Indian plains, Delhi, Agra, Jalandhar also somebody put that. Patna also somebody is putting that. Hajipur is 337. That's what Sachin is telling us. So everyone, please look at this. Did you realize and did you observe that post Diwali, this time we had sunny days. 2 sunny days. 2 दिन अच्छी धूप निकली है. In fact, after 1901, 120 years, we have the warmest October. Again, trying to connect it to current affairs, and especially because you give me weather reports. My intention about weather reports is not just to have some data from you. I am also saying that you keep on looking around geography which is happening around us. So post Diwali, people who are listening to me, I am in Delhi NCR. We have bright sunny days. Generally not happening in Delhi. And because of this warmth, instability, we had wind speed of around 10 kilometers per hour. यहाँ पे अभी किसी ने दिया हमें कुछ wind speed आई थी. Some student gave us Varanasi is 8 kilometers per hour. Normally does not happen around Diwali. So I am saying, if you go to the meteorologist today, he is saying that Delhi's pollution should have been 400 plus. Last year it was 400 plus was expected. 400 plus was expected. Schools band ho jate usme. Schools are shut down. There are, we have the special response program activated at that time. Special response program. So why is it not crossing 400? Why did it not cross 400? Because of the second factor, dispersal. Okay. So Ankush is writing to us from Dharamshala. He says air quality index is 65. Mountainous, hilly, forested, less populated area. Bhubaneswar air quality 118. Coastal, not exactly coastal. Coastal se thoda andar hai, but coastal influences, and we are looking at less populated compared to other. So Faridabad is 422, which is hazard. Yes, I'm saying, and people who woken up today in Delhi, I saw the wind today is very low, around 2 kilometers per hour. So for the next 10 days, Delhi NCR is going to have these high values. And the more the temperature falls, the more high pressure is created, the less second factor will be effective. So our dispersal will stop. If the dispersal stops, everything goes into it. Everyone, I hope you got some insights into our weather report today on air quality index. I think Print has come up with a very good article on air quality index yesterday, all about air quality index. If you can go and check on the Print, I think their website, you will find that on air quality index. A lot of questions are coming on prelims also, and even I do expect in mains, GS as well as optional, air quality index, particularly paper 2. Everyone okay? So we spent some 15 minutes. The idea was that as we are starting our class, let's warm up to the reality that is all around us. That is what geography is, not just the theory of it. So this was your weather report. So Lipun is saying the Print. Yes, the Print has come up with all about air quality index. A good article. If you look at that article, that will really make you exam ready. And my job is, like we're looking at current things, and I just gave you that data also. The warmest October since 1901 has been October 2024. This you can use all your attempts. If you want to give an example of global warming, use this. 1901 के बाद warmest October was 2024. That also led to the impacts on pollution and all those things. You can very well do that. Okay, so thank you for the weather reports, all people who participated. I hope you realize the utility of this report. Some of you may have this idea, अरे यार ये सब क्या बनाना है, क्या हम स्कूल के बच्चे हैं, are we school kids that he's making us do this? I'm again saying we are observing, and I believe that understanding atmosphere is a challenge. Why? Because atmosphere, when we are talking about, is invisible to us. To make it visible, we have to look at many things. Yes or no? Is everyone okay? Okay, so let's work on that. Arvind Kumar, is any role of hygroscopic nuclei in pollution? Arvind Kumar, which city are you from? कोई weather report भेजी आपने? So I would want you to first know what hygroscopic nuclei is. Maybe you've done your coaching. अगर कोचिंग की थी तो इसका आंसर आपके पास होना चाहिए था. Yes or no? और नहीं किए तो जब आएगा तब बता देंगे. Do we get that? हाँ जी. So let's work on this. Atmospheric pressure. आज हम क्या बात करने वाले हैं? We're going to talk about atmospheric pressure and pressure belts. That's what we are going to talk about today. We're done with heat budget of the earth. Temperature belts we've talked about. We're going to look into the pressure belts and some observations about them also. And then we are looking at atmospheric circulation, stability and instability that is going to come for us. Is everyone okay? हाँ जी, तो वापस आइए. So atmospheric pressure. So what is atmospheric pressure? What is atmospheric pressure? So we know we are living at the atmospheric pressure. We are living at the bottom of an ocean of gases, and a molecule of gas, say a gas molecule, is very light. Yes or no? It's very lightweight. True? Gas molecule is very lightweight. So if I'm standing, will it exert a force upon me? Remember, force per unit area is equal to pressure. Here the force is the weight of the gas. But the weight of the gas is minuscule. जब हम गैस की बात करते हैं, गैस मॉलिक्यूल का वेट तो बहुत ही मिनिस्क्यूल होता है कि नहीं? ट्रू और नॉट? So it is very minuscule. So हमें लगेगा, will we feel that? The gases which is around us, you can look around, you can feel around, move your hands. Do we feel the weight or not? Do we feel the weight or not? I want to tell you that average atmospheric weight which we are looking at is nearly 1000 grams. 1000 grams से ज़्यादा plus per centimeter square. That's what we are talking about. We are not feeling that. Everyone, please pay attention. 1000 gram मैंने इसलिए लिखा, the figure is different. 1000 gram means 1 kg. 1 kg per centimeter square. Everyone, please imagine. You are lying down on the ground. And your body is made up of centimeter square boxes. How many will you have? Imagine how much area in centimeters your body will cover. For every centimeter, there is 1 kg of weight. Imagine आप पर कितना weight होगा. Can you imagine what is the weight of atmosphere? So the molecule of a gas may be light. But when we take all the atmosphere that is above us, because there is not just one molecule. Say for example, if hypothetically I am a person whose area is 1 centimeter square. Imagine I'm saying it is not, but I'm saying will I have the entire air above me or not? True or not? So this is the air column. What is this? This is the air column above me. So atmospheric pressure is the weight of air column above a unit area. Exerted weight of air column above a unit area. Imagine हम पे कितना weight होगा. So that's it. So this is what the air column is. Sir, ये दिख नहीं रहा इसमें air कहाँ पर है? So everyone, can I make the air molecules like this? Is the air column shown correctly or not? Quickly tell me, is the air column shown correctly or not? 1 सेंटीमीटर स्क्वायर का एयर कॉलम मैंने बनाया. Is it shown correctly or not? Those dots are your air molecules. Is it shown correctly or not? तुम्हें लग रहा है तुम हवाई क्वेश्चन पूछोगे, मैं उनके जवाब दूंगा, पहले बेसिक तो दे दो. So those dots are your air molecules and the air column above me is weighing that. So Aditya says yes sir, air column अच्छा बनाया आपने. आयुष कह रहा है गलत है. गलत है तो सही बताओ, अगर किसी को गलत लग रहा है तो. People who are saying air column is right is okay. This is an air column of 1 centimeter square. 1 centimeter square. So unit area, weight of the air column above 1 unit area. Yes. So let me not take more time, because I said no, there are people who have done their coachings. There are people who have done their coachings and they have bigger things to talk and they don't know the basics. So that will happen, keep on happening. This has an error. The error is this. Niche, the molecules will be more. And as I go up, what will happen? The molecules will reduce. Do you get that? So as we go up in the atmosphere, does the atmosphere become rarer or not? Does the atmosphere become rare or not? So first of all, we are talking about air pressure, we are talking about air column. Do you understand the term air column? The weight of the air column is the pressure exerted. Yes or no? So that's what we are talking about. I hope you've understood that. So ये हुआ हमारा atmospheric pressure. So first thing is atmospheric. So how do we measure it? How do we measure it? How do we measure it? So there is a device. Device is called barometer. What is this device called as? Barometer. Barometer is a pressure measuring device. Yes. The units are bars and millibars. That's the unit that we are using. Plus. We also use a unit called as atmosphere. So barometer is the device. The units are bars and millibars, or we use a unit which is called the atmosphere. Average atmospheric pressure. Average atmospheric pressure at sea level is equal to 1013 millibars. Average atmospheric pressure at sea level is equal to 1013 millibar. These are some high points which I want to know about this term called as atmospheric pressure before we get into higher order things. And higher order things will come. Definitely they will be coming to you. A very important thing that I have put here is at sea level. What is the significance of at sea level? What is the significance of at sea level? Average atmospheric pressure at sea level. What is the significance of at sea level? If I don't write this average atmospheric pressure at sea level अगर हटा दूं तो does it make any sense or not? So pressure is always relative. Pressure is always relative. Relative means एक की तुलना में दूसरा. It is in comparison with other place. Yes, and for comparisons, all values are corrected to become corrected to हटाते हैं corrected for altitude. So with change in altitude, pressure changes. Ujjwal is saying baseline, sea level is baseline, and Raj Keshri is saying with change in altitude, pressure changes. Ayush is saying remove the anomaly of altitude. So Ayush and Raj Keshri have got it correct. Have got it correct. Shama Pandey is saying as we are going up, it is reducing. Absolutely okay. Say for example, I am in Tanzania. Where am I? I am in Tanzania. Yes, Tanzania has the highest peak of Africa, which is Mount Kilimanjaro. This is the base of Mount Kilimanjaro, and this is the tip of Mount Kilimanjaro, which is around 5,000 meters. So I am on ground or I am here. Imagine, will the weight change or not? So person who's standing at the top of the summit of Mount Kilimanjaro, उसके ऊपर का air column is hardly anything. But if I am standing here, then the entire column is on me. So though we are at the same point, geographical latitude might be the same, but our altitude has changed. So when you want to compare, say for example, I want to compare the pressure. Say for example, everyone please pay attention. The pressure in Delhi is 1020. Delhi में pressure है 1020. ठीक है? And Bangalore, the pressure is, say for example, 1008. Now please remember, Bangalore is located at a height of 1 kilometer. Bangalore is having an altitude of 1 kilometer and Delhi is on ground. So as it is, Delhi's pressure would be more or not? Yes. So if I want to compare the two pressures, then what will I have to do? I'll have to bring Bangalore down to this. Then only they are comparable. Do you get that? So never compare pressure of two places at different altitude without applying correction for altitude. Is everyone okay? So whenever you're comparing two places, make sure that the value of the pressure is at sea level. Then only they are comparable. Is everyone okay with this? So right in the beginning, certain things which I wanted to talk about. Barometer दो तरह का होता है. एक तो श्रीमान टोरिसेली ने बनाया था. टोरिसेली बैरोमीटर. ये किससे बना है? This is the mercury barometer. This is mercury barometer. Have you seen mercury barometer? How many of you have seen mercury barometer? How many of you have seen a Torricelli barometer? Have you seen a Torricelli barometer? How many of you? I have लिख दो. अगर आपने देखा है Torricelli तो आप लिख दो I have. Or you can write down Torricelli. और दूसरा बैरोमीटर होता है एनोरॉइड. एनोरॉइड बैरोमीटर. So Natasha has seen a Torricelli barometer. Not that we need to, but Jyoti has seen a Torricelli barometer or a mercury barometer. Suman has seen. So I want to tell you that all students ऑल स्टूडेंट्स, मनप्रीत सिंह जी पहले आप ये बताओ जो हम पूछ रहे हैं, आपको पता है कि प्रेशर की हाइट के साथ रिड्यूस होने से रेट क्या होता है? अभी बताएंगे ना प्रेशर वेरिएशन, पहले प्रेशर का तो जवाब दे दो। आपको लगता है बाकी सब आता है मनप्रीत आपको, बाकी सब तो बेवकूफ है, आप इसका तो बताओ, आपने टोरिसेली देखा कि नहीं देखा? ये ना हमने चैट डाला उसके बाद, और अगर आपने एनसीईआरटी पढ़ा है, एवरीवन हैव यू रेड एनसीईआरटी? एनसीईआरटी में इसका जवाब है मनप्रीत सिंह जी। तो अचानक बात से बात नहीं निकाली, अगर बात से बात निकाल रहे, इफ यू रेड समथिंग यू स्टक समवेयर, आई अंडरस्टैंड। अगर बात से बात के लिए डाउट निकाल रहे, प्लीज अवॉइड दैट, बिकॉज आई विल बी कवरिंग दैट, आई विल बी कवरिंग दैट समवेयर. So very few people have written I want to tell you all the science students जिन्होंने 11th 12th में साइंस लिया था, you have seen a Torricelli barometer. It's just that it never registered and our sciences are very theoretical. But अगर आप physics lab था आपके स्कूल में, तो physics lab में वो लगा हुआ था. So we're talking about this. Pressure meaning variation with altitude जो मनप्रीत पूछ रहे, उसके बाद अभी हम बात करेंगे उसके बारे में. ठीक है, हाई एंड लो प्रेशर क्या होता है, प्रेशर डिफरेंस लीड्स टू मूवमेंट ऑफ एयर, दिस इज व्हाट वी आर गोइंग टू टॉक अबाउट. सो फर्स्ट ऑफ ऑल दिस इज द बैरोमीटर विच यू वुड हैव सीन. जिन लोगों ने नहीं देखा, अच्छा ये वाला था. इनफैक्ट देयर इज दिस टेस्ट ऑल्सो, एक मेरे ख्याल से हमारे टाइम में बोर्ड एग्जामिनेशन में वी वर ऑल्सो गिवन एन एक्सरसाइज लाइक कि मर्क्यूरी बैरोमीटर की रीडिंग कैसे ली जाती है, अपर या लोअर. दैट्स व्हाट वी हैव डन. बट सो मेनी पीपल आर, मैंने कहा ना क्लास में बात से बात निकालने वाले हैं. आईएएस का preparation is a very structured preparation that you take baby steps and you reach the higher level. It is not about just debating and saying oh vertically थोड़ा बदलता है क्या, क्या रेट होती है इसकी. टशन बंद, एक्शन पे आ जाओ. ठीक है. So individual molecules weigh almost nothing. Individual molecules no, but atmosphere as a whole has considerable weight. I told you around 1000 grams, जिनको वैल्यू चाहिए 1034 grams per centimeter square. And this is Evangelos Torricelli. A student of Galileo performed an experiment that was on the basis of invention of a mercury barometer. So mercury barometer क्या होता है, ये होता है. This is called the Torricelli tube. इसके अंदर क्या भरा हुआ है, mercury भरा हुआ है. So how are they measuring it? Anyone? How do they measure the pressure? 76 centimeter of mercury. Any of you remember how do they measure the pressure? So what Torricelli did was, Torricelli ने क्या किया? Torricelli said that the atmosphere is exerting pressure. Yes or no? So atmosphere is exerting pressure. True. So what he did was he filled up mercury. उसने क्या डाला? He filled a tub full of mercury. Yes. And then he took a test tube. Or whatever we are calling it, the Torricelli tube, and kept it here. What is this? An empty test tube. What is this? An empty test tube is there, or Torricelli tube. And what is this? This is mercury. And this is the tube. Now what happens is, if the pressure is there, what will it do? It will force the mercury to rise. Why will it force the mercury to rise? Because there is pressure on that, it will rise. It will rise to a level, and it will stop at that level. And mercury का आप जानते हैं थोड़ा upper minuscule लेते हैं. Yes. Why would the mercury stop? Why would the mercury rise? Rise is easy, everyone. It will rise because of the pressure. Why does it stop at a particular height? 76 centimeter. Why will it not rise any further? Because now there will be weight of mercury column will balance the weight of atmosphere. Yes or no? Now I have a question. Atmosphere is so many kilometers high. Whereas mercury is just 76 centimeter. How can a 76 centimeter liquid equal hundreds of kilometer level fluid? Simple science. How 76 centimeter of mercury fluid can equal the weight of hundreds of kilometer of atmosphere? Anyone whose basic science is done will get the right answer. So because mercury is very very dense, atmosphere is not dense. एटमोस्फियर को अगर पूरा उसको श्रिंक किया जाए तब इतना आएगा 76 सेंटीमीटर. Amazing. Okay everyone, I have another question. If you are saying that it is because of density of mercury, if Torricelli had not taken mercury, if he had taken water, can this experiment be done? Instead of mercury, if he had taken water, can this experiment be done even with water? Yes or no? बेसिक साइंस यार. हमने देखा है ज्योग्राफी के टीचर एटमॉस्फेयर के नाम के नोट्स लिखवा रहे, ये होता है वो होता है. So people are saying it will not happen. There is a student Kuldeep is saying it will happen, but the water will rise more. Ayush is also saying that. So Kuldeep and Ayush are correct. If mercury can balance air, because mercury is denser than air, so can water. Why not? Water can also do that. But remember, water is not as dense as mercury. So water will not stop at 76 centimeter. Water will take more height. And you know what? How much? Almost 10 meters चाहिए. Almost 10 meters of water is needed to balance the atmosphere. Now imagine a 10 meter की ट्यूब बनाना टोरिसेली के लिए मुश्किल था. तो टोरिसेली ने दिमाग लगाया. टोरिसेली took a very very dense fluid, mercury, which is fluid at room temperature. Smart or not? Yes or no? So water से भी हो जाएगा. Water का भी एक column बनेगा. Water will balance, but water being less dense will take almost 10 meters. So Ayush, Kuldeep got it correct. Rest who said no, it is not possible. It is possible यार. Anything, अगर यहाँ पर एयर है, एयर से कुछ भी डेंस लोगे तो बैलेंस तो करेगा ना. सो वाटर तो बहुत ऊपर तक जाएगा. यस कृष्णा, आई टोल्ड यू अराउंड 10 मीटर्स. खत्म करें इसे. दिस वाज बेसिक साइंस. People don't respect the basic science, so I begin with basic science. I have seen, geography teacher just impressing students by, random words, big words here and there, and the students are also writing, not realizing what they're doing. So everyone, we have a lot of pressure being exerted on our body, which is almost 1 kilogram per centimeter square area. So which makes it very much, like if we have 100 centimeter square area, तो वो कितना हो गया? 1 kilogram means 100 kilogram तो हमारे ऊपर वजन आ ही गया. Yes, more surface area means more. That's what we are talking about. So what I want to tell you is that there is a lot of pressure on us. You and I are moving freely, no impact on that, because the air inside my body, the fluids inside my body, the cellular fluid, the blood which is being pumped in my body, everything by biology, by God's evolution design has already become equal to the atmosphere. We have adapted to it. So the pressure inside my body, be the air, be the fluids, be the blood that is flowing into it, my heart is pumping at the same pressure so that whatever atmosphere is pushing me down, I am not impacted by that. But I will feel that only when there is an imbalance in it. So my body is used to a mean sea level pressure, which is 1013 millibar. But if you take me to a mountain, like Kilimanjaro, remember Kilimanjaro to ab height pe chale gaye. So will the pressure reduce or not? Will the pressure reduce? Why? Because Kilimanjaro, I am already at a height. So can you see the air column above me is smaller? Yes or no? This much air is not weighing on me. So with height, what happens? The pressure will fall down. Pressure will fall down, but my body is still pumping at 1 atmosphere. So an imbalance will happen. So you would have heard of that people who go to the mountains, their nose starts bleeding. Their blood vessels might burst. Those tiny blood vessels of the nose will burst. Another thing that happens with altitude is everyone, it's all about pressures. It's all about pressures in our body. When I am breathing right now, I am taking air in my lungs. Yes? And the pressure of that air is enough to push oxygen into my blood and take away carbon dioxide. Yes or no? So the air, atmospheric pressure is important for the gas exchange in my lungs. Please remember that. When I go up in altitude, when I breathe, the air pressure is low. With that low pressure, when the air goes in my lungs, it is not able to effectively exchange the gases. So my blood is not able to take the oxygen which it normally would have taken at sea level. So what will happen? I will start panting. I will start gasping for air. Why? Because I am breathing. But breathing is not just about, taking in air and inhale and exhale. It's a very big chemical reaction, biochemical reaction, which is happening in my body. So if that pressure is not enough to cause that gas exchange in my lungs and the blood vessels, I will feel, even after breathing, the need to breathe more. So at altitude, people suffer from breathlessness and gasping and panting also. The opposite will happen that instead of rising up, if you go down, say for example, you dive into the oceans, you go down. So first of all, the atmosphere weight is more, and this time to not only atmosphere, even the hydrosphere weight is on top of you. There you will see a lot of crushing pressure on you. Remember submarines? They can get crushed because of that pressure. So they have to maintain that pressure. Even in an aircraft, they have to maintain a pressure which is normal to us. Is everyone okay about the practical aspects of pressure and pressure changes? Everyone with me on this? Torricelli, done. This is Torricelli, air pressure, mercury rises. कहाँ तक आएगा? 76 centimeter. If you put in some other fluid, the experiment will happen, the height will change. Depending on the density of it. Ujjwal is saying Ocean Gate submarine. Yes, if you've heard of that submarine which went down in Atlantic, got crushed, so that's there. Now this barometer is not easy to handle. आपने देखा होगा almost 76 centimeter ना, तो 1 मीटर लंबा होता है. So it's a very big challenge to carry it. It's not easily portable. और fluid है, fluid इधर उधर करेंगे तो problem है. नीचे इसमें mercury chamber है. So what they've come up with? They've come up with this. This is the barometer. Where can you see this diaphragm? This diaphragm will shrink, expand, shrink, expand. Here we have vacuum in this diaphragm. This diaphragm is your vacuum chamber. So what happens is, if the pressure is more, what will happen to this diaphragm? ये shrink हो जाएगा. ये diaphragm क्या होगा? छोटा हो जाएगा. छोटा हो जाएगा तो इस पे एक पेन लगा हुआ है. The pen will move and it will get recorded on this paper. This is called barograph. Barograph. where you're constantly reading. If the pressure is low, the diaphragm will expand. If the pressure is low, diaphragm will expand and the pen will move accordingly. And here we have a recording coming in. This is not having mercury in it. This is having vacuum. Vacuum is devoid of air. That is called aneroid barometer. Is everyone okay? अभी स्कूल में सिखा दिया जाना चाहिए था. अगर नहीं सिखाया तो कोई बात नहीं. My job to just understand that air that is acting here, either here or on this vacuum chamber, will decide what the pressure is, and we have found out ways to measure it. Atmospheric pressure. Is everyone with me on this? Chaliye, let's look at the variation of pressure. Next thing which I want to look at is everyone, if you have any question about the definition of air pressure, atmospheric pressure, please ask that. Other questions, leave it to me. They will come. I have all the things lined up for you. I just want you to understand. Are we done with this? If we are done with this, you can write down done. Okay, thank you for that. Chale. So variation of atmosphere. So atmospheric pressure changes or varies spatio-temporally. So this should stay with you. ये spatio-temporal आपकी language में आना चाहिए. Wherever we are talking about variation, we are talking about spatial and temperature. Oh, sorry, time. With space and time. So when we are talking about spatial variations, I'm going to explain both of them. Get that? Atmospheric pressure changes both spatially and temporally. Get that? And these variations, the spatial variations, can be because of vertical and horizontal categories. Two type of it. And when we are talking about this, when we are talking about the vertical and the horizontal, so in horizontal variations, I want to tell you that due to two types of factors, thermal and mechanical. Temporally, seasonal variation induced pressure variations. This is broadly, one page that if you are asked a question on examine the variation of atmospheric pressure, you will have to talk about 1, 1A, 1B and 2. That's all. ठीक है, शुरू करें. Let's talk about altitudinal or vertical variations of pressure. Okay. For that we need to understand something called as a high pressure versus low pressure. So what is high pressure and low pressure? What does the condition mean? High pressure and low pressure, first of all, they are relative terms. First is these are relative terms. So there is nothing called an absolute value. An absolute value does not mean high or low pressure. An absolute isolated pressure value can be both high or low pressure when seen relatively. Very, very important. That's what we are talking about. Say, for example, 1030 millibar, high or low? 1030 millibar is how high or low? Sir, atmospheric pressure is 1013 compared to average atmospheric pressure. This is high, so this must be high pressure. Yes or no? So 1030 millibar, will it be high or low? Quickly tell me. 1030 millibar, will it be high or low? People are writing high, so it always depend on the surrounding values. If the surrounding values are 1032, that's what I've written. Many people are still writing high. So we never write, a pressure with respect to mean sea level. जब मैं mean sea level पे हुई नहीं. Yes or no? It also depends on the season. Yes or no? So the reference has to be there. If instead of this, if it was, now it is low, if it was 1028, then what will happen? It will become high. Is everyone okay? So it is always relative. That is what I have written. That's one thing. Second thing is, say for example, we are here. I am at spot A, I am at spot B. Both are at mean sea level. So to make my life easy, I have brought two things which are at mean sea level. Now, which one is high pressure? Which one is high pressure? This one or this one? A or B? Which is high, which is low? Sir, A is high. A is high. B is low. Why? Because A has more molecules. More molecule in that unit area. In this unit area, suppose this area is 1 centimeter square. This area is 1 centimeter square. जिसके पास ज्यादा गैसेस होंगी वो क्या हो जाएगा? वो ये हो जाएगा. ठीक है. A and B at same altitude. A and B same altitude. Now let me change A and B. A is here, B is here. This is mean sea level. Now tell me which one will have high pressure, A or B? A or B? A or B? Which one will have high pressure? Pressure decreases with altitude. So A will have high pressure. Why? Why? Quickly tell me why. आपके सामने ही आंसर है. Why pressure decrease with altitude? Mank is saying lower area is more dense. Yes, absolutely okay. But why? More force per area by air column. रोशनी वो तो ठीक है, but उसका सही वो करना है. Because of lower molecular weight is less. कुलदीप molecular weight नहीं लिखेंगे. Everyone आंसर बनाने के लिए क्या करेंगे? We will make this. So first reason, Bhaskar is writing absolutely okay, sir. A, half of the atmosphere. Air column B. Air column A. So which has a bigger air column above it? A or B? A or B? A, simple. So first reason is the air column length reduces with altitude. आपके ऊपर एयर कॉलम ही छोटा हो गया कि नहीं हो गया? If the air column is smaller above you, you're not having the weight of the entire atmosphere. Very simple reason, simple logical reason. Second one is air at higher altitude is rare, less molecules. Air at low altitude is denser. Dense atmosphere, rare atmosphere. Remember we use the term rare for what? जो कम होता है. Yes or no? So second is the density of atmosphere reduces with altitude. Simple English. Simple English and the right reason or not. I knew that you have the understanding. ऐसा नहीं है इस क्लास में किसी के पास अंडरस्टैंडिंग नहीं है. Dense molecule sink down. अब मोहित साहू ये लिख रहे हैं, but that does not convey that. Yes or no? Due to dense air below, that is Abhishek. Yes. Amrit Pratap is saying air is rarefied. A has more weight above it. A is half of the atmosphere, more weight because B has less molecule. Everything. I know all of you knew the answer. All of you knew the answer, but does the writing, the two sentences, the language, does it change and have a precise hit or not? Everyone, we are talking about vertical variations of pressure. We are talking about vertical variation of pressure. And we have given two reasons for this. That as we change the height, the air column above us changes. The longer the air column, the more is the weight. That is one thing. And the second thing is, नीचे की हवा ज़्यादा dense होती है, वहाँ ज़्यादा molecules होते हैं, ऊपर कम होते हैं. Is everyone okay? Is everyone okay? And did I tell you about this also, the generally the empirical rule? The empirical rule, आई थिंक हमने एटमॉस्फेयर के कॉम्पोजिशन में किया था, स्ट्रक्चर ऑफ एटमॉस्फेयर में, रिमेंबर स्ट्रक्चर ऑफ एटमॉस्फेयर. सो अप टू 5.6 किलोमीटर 50% एटमॉस्फेयर, 50% एटमॉस्फेयर, ऐसा कुछ किया था कि नहीं किया था? डिड वी डू दिस? देन वी वेंट टू 16 kilometers. We said 90% here, 10% here. Then we went to 32, 99% here, 1% here. ऐसा कुछ था? Remember this? So already done that. So इधर क्या है? Denser. इधर क्या है? Rarer. Yes. यहीं पर आपका ओजोनोस्फीयर था, रिमेंबर ओजोनोस्फीयर. दिस वाज ट्रोपोस्फीयर. सिंपल कनेक्शन, बेसिक कनेक्ट करो, यू विल गेट दैट. इज एवरीवन ओके? नाउ आई हैव अ प्रॉब्लम. I talked about such a thing with temperature. Fall of temperature with altitude. Remember? Same comparison जो हमने पहले पढ़ा है. That was called lapse of temperature. Lapse of temperature. Get that? Second. Average atmospheric lapse rate was equal to 6.5 degrees Celsius per kilometer. Yes or no? Already done. So fall of pressure should be called lapse of pressure. Yes or no? So we don't use lapse of pressure. We use vertical gradient of pressure. So what we have learnt in temperature, I am bringing the same thing here. Get that? Change in pressure with altitude is called vertical gradient of pressure. We don't call it lapse of pressure. Lapse of temperature उधर चला गया. ठीक है? Now इसकी भी एक lapse rate होगी. Yes or no? So the vertical gradient is highly variable. Yes, both spatially and temporally. बहुत ज़्यादा वेरी करता है. Vertical gradient of pressure is highly variable, both spatially and temporally. Therefore, no average value assigned at a global atmospheric level. So somebody asked this, sir, vertical में क्या rate होता है and all that. So that rate keeps on changing and very, very high changes are there, and as a result they have not ascribed any fixed value to it. Is everyone okay with the vertical variation thing? Is everyone okay with the vertical variation thing? High pressure, low pressure, denser, rarer, air column. Yes, if you are okay with it, please write done so that I can move to what other things I have to tell you. किसी ने पूछा था सर इसकी रेट क्या होती है, मैंने कहा था वेट करिए आएगा. सो आई होप दैट हैज आल्सो बीन डन. Done? Chale. Thank you for confirming. Now I have one more thing to talk about since I'm talking about vertical this thing. So the word cyclone or cyclonic or depression. Terms signifying low pressure. Do we get that? Whenever you see the word cyclonic or a depression, please do not consider it as a storm. Cyclonic storm is something. So cyclonic word means low pressure. Get that? Another word, if you see, is anticyclonic. Anticyclonic means high pressure. Is everyone okay? Surface cyclone will have an upper atmospheric anticyclonic condition and vice versa. Very, very basic things. We are looking at that. When these basic things are done, we are able to do circulations and your doubts will be clear. If there is a surface cyclone, surface means ground surface, and it will have an upper atmospheric anticyclone. Get that? बना के दिखाता हूं. Let me make it for you. Location A, location B. Okay. Air column A, air column B. Hundred molecules are there. 100 molecules are there. Total 100 molecules. Temperature is 0 degrees Celsius. Let's simply write down this. B is temperature 46 degrees Celsius. Two locations are there. Location A is at 0 degrees Celsius. It has 100 molecules. Location B also has 100 molecules in its air column. It is at 46 degrees Celsius. Okay. Now let's talk only about A. Let's talk only about A. Where are more molecules? Bottom or top? Bottom or top? Where are more molecules? Bottom or top? So 100 molecules are there. Where are more molecules? So they are on bottom. Why? Because atmosphere, the gases, they sit with their weight. नीचे भारी रहती हैं. Perfectly. So more molecules at the bottom. Okay. Now please tell me, is that true for B also? More molecules at bottom. Is that true? प्रज्ञा यादव इज सेइंग सिंकिंग एयर. बेटा सिंकिंग एयर की बात नहीं, सिर्फ एयर की बात हो रही है. अभी एटमॉस्फेयर बताया, गलत चीज मत समझो. यहां पर हमने कहा यहां पर हमेशा ज्यादा मॉलिक्यूल होते हैं. यहां पर ज्यादा मॉलिक्यूल होते हैं. प्रज्ञा थोड़ा सा दिमाग लगाइए, ऐसे मत कर दीजिए. हमने सिंकिंग का वर्ड नहीं यूज किया है. आप जहां से भी पढ़ें, आई डिड नॉट टॉक अबाउट सिंकिंग. नॉर्मली एज अ रूल it is going to be there. Will B also have more molecules at the bottom? Yes or no? So Kuldeep has the right answer, yes. He's saying, yes sir, even at B there will be more molecules at the bottom. वो तो रूल है ना रोशनी, everywhere there will be more molecules at the bottom. सोच के देखो, किसी भी गैस में molecules at the bottom will be more. The denser air, the denser ones नीचे आते हैं, हमेशा ये होगा. उनका भी तो ट्रोपोस्फियर होगा ना, true or not? But there is a difference. So everyone, let me make it for you. Let me make it for you. Maybe you will understand. Yes, maybe 80% are here and or 90% are here, 10% are here. True or not? And here 100 molecules, what will happen? Here also we have 100 molecules. Maybe 70% and 30%. Do you agree? Because this was cold, I do agree. कोल्ड में सब नीचे चले गए, है तो 100 ही ना, 100 बटेंगे, 100 बटेंगे. This is cold. So can I say cold, heavy, gas stays closer? Can I say this is the situation at the poles? Can I say this is the situation at the poles? Probably this is the situation at mid-latitude desert, mid-latitude desert. Yes, the air is warm. So what is happening? Convection. Yes or no? So instead of warm, they will be lighter. True or not? रोहित सिंह कह रहा है हवा ऊपर की, तो भेज तो दिया चाचा हवा, कितना जाएगा ऊपर, भी तो ठंडी होती है. मेरा एयर राइजिंग, उसकी भी तो एक लिमिट होती है कि नहीं होती है? So can I say on the pole the air is heavy and sinks? Heavy air, heavy cold air नीचे, और इसमें क्या है, इसमें वार्म एयर है, टेंडेंसी टू राइज, बट उसमें भी कितना राइज करेगा, ऐसे थोड़ी कि ऊपर पहुंच जाएगा वो. एवरीवन विद मी, इसलिए मैंने कहा होमवर्क दिया था कि पढ़ के आना. ठीक है रोहित सिंह जी, मिल गया आपको जवाब. तो ऊपर ले गए हम उसको, बट थोड़ा ही जाएगा, रिलेटिवली लेस. ठीक है. नाउ एवरीवन प्लीज टेल मी, कैन I compare the pressure of X and Y? Can I ever compare the pressure of X and Y? Is it right to compare the pressure of X and Y? No. We always compare the pressure at same altitude. Yes or no? True or not? यहां पर है X डैश, यहां पर है Y डैश. True or not? So what should be compared? X with Y or X with X dash? X with Y or X with X dash? So tell me, which one is high pressure, Y or Y dash? Which one is high pressure? Y और Y dash में which one has high pressure? दोनों में 100 molecule थे. Both of them have 100 molecule. Which one is high pressure? Sir, Y is high. तो लिख दूं Y is Yes. So at poles on the surface, what do I have? High. And what do I have at 30 degrees or in warm areas? Not ये 30 degrees और दूसरे रीजन से है, बट इन वार्म एरियाज ये क्या हो गया? लो. True. Okay, tell me something about x versus x dash. X versus x dash. Which one is higher? Which one has higher pressure? Sir, x dash has higher pressure. साइन बदल गया. एट अपर ऑल्टीट्यूड ये हाई है और ये लो है. Can I, everyone, can I write down that if you are cyclonic or anticyclonic on the surface, you are cyclonic above, and if you are cyclonic below, then you have an anticyclone above you. Everyone, do you understand the meaning of this? Surface cyclone will have an anticyclone in the upper atmosphere. Can I call this as upper atmosphere? Can I call this as surface? And vice versa. Surface पे anticyclone है तो ऊपर cyclone होगा. If everyone understood, please write done. And you should have drawn this also. Done? Simple? Okay. Rule is the atmosphere always tries to balance. So air always moves from high pressure to low pressure. Air always moves from so if I am to draw the wind, can I say the wind will blow from here to here and in the upper atmosphere from here to here? अभिषेक कह रहा नाइस सर, कोई भी पूछे अब इजीली एक्सप्लेन कर सकते हैं. हाँ, एग्जामिनर पूछेगा, पड़ोसी को नहीं बताना है कि पड़ोसी को इम्प्रेस करने के लिए जवाब दे रहा है. फॉर द एग्जामिनर. इज द विंड करेक्ट? तो जब भी विंड चलेगी वो कैसे चलेगी? हाई प्रेशर से विंड बाहर को निकलती है, लो प्रेशर पर विंड ऊपर को आती है. आई नो सम ऑफ यू आर जेलस. सचिन सर, यू हैव सो मेनी कलर्स. मेरे डायग्राम का तो कचरा हो चुका है. अरे दिस इज योर क्लास. एक ही स्क्रीन पे सब कुछ इसलिए बनाता हूँ सो दैट यू नो हाउ टू मेक योर नोट्स. यू कैन मेक योर नोट्स. आप अपने अच्छे नोट्स बनाओ, क्लास के बाद भी एक बार करेक्ट कर सकता है. यस सुनो. डन. डन हो गया. एयर ऑलवेज मूव्स फ्रॉम हाई प्रेशर टू लो. वो देखो, रोशनी कह रही है सर इन बी ऑल्सो ऑन सरफेस लेवल इट इज एंटी साइक्लोनिक बिकॉज देयर इज हाई प्रेशर. इन बी एंटी साइक्लोनिक क्यों है? सरफेस पर, सरफेस पे क्यों है? इन दोनों का कंपैरिजन आप इधर से क्यों कंपेयर कर रहे हो? कंपेयर किससे होता है? कंपेयर नंबर ऑफ डॉट्स से होता है ना. इधर भी डॉट्स हैं, इधर भी डॉट्स हैं. इधर 90% है, इधर 90 मॉलिक्यूल्स हैं, इधर क्या है? ओनली 70 मॉलिक्यूल्स. सो दिस इज हायर, नो. 90 इज मोर देन 70, इसलिए आ रहा है. और क्योंकि रिलेटिव है तो 70 मेक्स इट साइक्लोन, 90 मेक्स इट दैट. डिड वी अंडरस्टैंड और नॉट? कुछ लोग अभी भी ऊपर से कंपेयर कर रहे हैं, सर ये भी तो हाई होगा. नहीं नहीं नहीं, यू डोंट कंपेयर इट विद दिस. You always compare high pressure and low pressure at the same altitude. So you will compare Y with Y dash. Y has 90 molecules. Y dash has 70 molecules. So 90 wala is high pressure. अब ऊपर आए, he has 30 molecules, X dash. X has only 10 molecules. वहां पर ये हाई हो जाता है, इसलिए करवा रहा हूं ये. जो लोग मुझे ऐसे सुन रहे हैं ना कि सर समझ में नहीं आते, दिल में आते, छोड़ो, बनाओ. If you are drawing it, you got it. If you are drawing it with the intention I told you, and this diagram has the reasons also. Reason भी डाला है, सब कुछ इसी में डाल दिया. Did we get that? कौन था ये? Who was this? रोशनी. I hope रोशनी you got that. एक बार फिर से देख लेना अगर नहीं समझे तो. I want to go to plate tectonics. I want to go to plate tectonics. I want to remind you of two words, convergence and divergence. Remember the word convergence and divergence? Convergence and divergence. Can you tell me which one is associated with convergence? Low pressure or high pressure? देख के बताना है. Convergence कहां पर होता है? Low pressure or high pressure? It will apply at all heights. This rule will apply. Convergence is associated with low pressure or high pressure. So wherever you see convergence means low pressure. अगर वहां लिखा भी नहीं हुआ है, so this is a smart way. Winds can tell us where the low pressure is. Even if I don't have a barometer, if I see the winds are converging at one place, that is the location of low pressure. और सबको एयर कौन बांटता है? Who distributes the air? जहां से डाइवर्ज होती है, the one who has a lot of air with it. So air will always diverge from where? Air will always diverge from where? Divergence कहां पर होता है? Divergence will happen where? High pressure, sir. Anticyclone. देखो सब लोग आंसर लिख रहे हैं यार, all smart people. It's just that you need to set the explanations right. If you're following me, if you're drawing the diagram, सारे question हट जाएंगे यार. Your climatology is that easy. But the problem is पहले दिन टीचर फंडा देगा और पता है इससे जेट स्ट्रीम चलती है, फिर वो घूम जाता है, कोरियोलिस फोर्स उसको घुमा देता है. ये सिर्फ मैं बताऊंगा आपको, आगे बताऊंगा, मुझे आता है. चाचा, you don't have clarity, that is why you're doing that. पहले तो ये करेगा कि नहीं करेगा? Is everyone okay? Winds are always named after the direction they are coming from, and winds converge at low pressure, wind diverge at high pressure. High pressure is an anticyclone, so anticyclone से wind बाहर आती है, cyclone से wind अंदर जाती है. Everyone okay? Did we understand this also? Did we understand upper atmosphere also, lower atmosphere also? Did we also understand lower atmosphere will always have more air, but depending on its temperature, the lower atmosphere may have the air expanding. इधर क्या हो रहा है? Expand हो रही है, इधर contract हो रही है. Everyone okay? Vertical variation, and the rate changes with altitude. वर्टिकल वेरिएशन ऐसा ही आया कुछ, नीचे ज्यादा होता है. सो द एयर डेंसिटी इज ऑलवेज हायर एट द बॉटम, ऑलवेज, वेदर यू आर इन द वार्म एयर और इन द कोल्ड एयर. इफेक्टिवली इसकी तुलना में कंपेयर टू टॉप, दिस विल ऑलवेज बी मोर, बट हॉरिजॉन्टली इट कैन बी डिफरेंट, विच आई हैव शोन यू. दिस इज द फर्स्ट थिंग विच वी हैव डन दैट. Second thing is high and low pressure. So this is the normal situation. So where is high pressure? More particles here, less particles here. But we don't compare them. We always compare the same height people. So when we have the cool and the dry air, what is the tendency? Heavy. So cold areas, high atmospheric pressure. Warm areas, what will happen? the air has a tendency to rise. That will always be there, that it is there, but it will be less on this. और यहाँ पर high pressure, if the air has to move, where will it move? High to low, high to low. Is everyone okay? And relatively, we are looking at the air moving there also. What are the horizontal variations? So have we done with vertical variations? Vertical variations हो गया ना? Okay. चलो, vertical variations are done. Everyone, are we done with vertical variations? So ये मेरा पहला topic था, vertical variation of pressure, so that you understand. Now these are just examples. These are just example. I want to tell you this 100 centimeter or 100 molecules. Let us write there as hypothetical example. किसी से लड़ मत जाना. A meteorologist can challenge you on this. He will say that as the air expands, it will go out of the column. So don't be a meteorologist. वो मुझे पता है, इस explanation में I know how to answer those explanations also. I know how to answer those explanations, but you do not. You are just geography students, so keep it to that. हाँ जी सर, now I understand flight जब surface पे land करता है तो कितना pressure होता होगा. So definitely not only that, remember we lost our astronaut Kalpana Chawla. Yes, आप तो फ्लाइट की बात कर रहे हैं. जब वो स्पेस से द स्पेस क्राफ्ट एंटर्ड द अर्थ्स एटमोसफियर, उसको फ्रिक्शन मिलेगा, मिलेगा कि नहीं मिलेगा? फ्रिक्शन भी होगा, उस पर प्रेशर भी होगा. इट्स कमिंग फ्रॉम वैक्यूम एंड they are generally having a very important coating on that, which will take on the heat also. The thermal coating had a crack on it, and because of that, that spacecraft Columbia just exploded upon before landing. At first I was scared of geography. Now feel easy with concept. See, the more you understand the concepts, the things will become easier. But again saying, please revise. And it is not just about understanding. You have to write also. So that is why I'm saying, अपनी भाषा के लिए NCERT जरूर पढ़ें. Horizontal variation of pressure. Sometimes also called the latitudinal variation. Understood using a global isobaric maps. Okay. अंकुश बोला सर थर्मल कोटिंग ठीक नहीं कर सकते थे बिफोर लैंडिंग, स्पेस मिशन थे तब. तो ऐसा नहीं होता कि स्पेस से निकल के वो करेंगे, और उन्हें नहीं पता था कि वहाँ पर वो क्रैक है. डू यू गेट दैट? सो से फॉर एग्जाम्पल व्हेन वी हैड rains in Dubai this year, yes or no? So Dubai is known for its amazing buildings and tall buildings. वहाँ पानी नहीं आता. This time when it rained, what happened? The roof started leaking. So they got to know, oh my god, इतना बारिश होता है तो पता चलता है. टेस्ट भी तो होना चाहिए. So there was no doubt that the coating was cracked on that. हमने देखा यहाँ पर पुल बनते हैं, सरकार पुल बनाती, पुल टूट जाता है कि नहीं टूट जाता है? तब तो क्रैक नहीं दिखते. when the government is passing those inspections and all that, okay, looks good, चल पास किया, funds are released. But the real test lies in the rainfall or not. रेनफॉल में तो मंदिर तक में हमारे पानी गिर गया था कि नहीं गिर गया था? तो ये बोल रहा है सर स्पेस में अगर क्रैक हो गया तो तोड़ के सही नहीं कर सकते. अंकुश ऐसे हाइपोथेटिकल मत हो जाओ, भावनाओं पे कंट्रोल करो. ग्लोबल आइसोबारिक मैप, हम आइसोथर्म का मैप देख चुके, वी हैव ऑलरेडी लुक्ड एट दैट. यस नो, दैट्स व्हाट वी आर टॉकिंग अबाउट, हॉरिजॉन्टल वेरिएशन ऑफ प्रेशर. So when I'm talking about horizontal variation, it will be at sea level. Everything will be at sea level. Okay. So first of all, the pressure variations at surface occur on account of two factors. Thermal factors Yes, controlled by insolation. And second is dynamic factors. On account of Earth's rotation. Okay. Controlled by insolation. So first is differential heating across latitudes, land and ocean differential and topographic and surface variations. They create differential heating things. ठीक है. Coriolis deflection induced air motion. Get that? Centrifugal force induced. See, when you're writing the answer, you will have sufficient. जो हम क्लास में करा रहे, whatever is done at KGS class, there is enough to talk about it. आपका टॉपिक इसमें क्लियर हो जाएगा. Your concepts will be clear. If it comes as a statement in prelims, you'll be able to make out. If it comes in mains, that can be there. Now, I generally don't have a tendency to, impress students with something, like which is out of the world. कुछ ऐसा बता दो कि भैया वो आपने सोचा ही नहीं, समझ नहीं आ रहा, और समझ के बिना भी बस यू आर सेइंग सी यू डोंट हैव टू बिकम अ साइंटिस्ट, जो मैंने कहा वो लिख दो. नहीं भाई, जो बताऊंगा वो आपको समझ आएगा. That will be there. And the second thing is that will be sufficient to clear the exam with good marks. That's what we are talking about. So I have a request that whatever you're doing, have trust on that. Have trust on that, read about it, and above all, rather than running here and there, work on your concept and language. No institute talks about language. कोई नहीं करते क्योंकि उन्हें फुर्सत नहीं अपना इंप्रेस करने से. आई एम सेइंग इफ आई इंप्रेस यू, आई बिकम अ हीरो, यू बिकम अ जीरो. मैं आपके लिए, मेरा काम है ना डाइजेस्ट करना. फालतू की रैंडम चीजों को, क्लटर को हटा के आई विल कट अवे द क्लटर एंड आई विल डाइजेस्ट एंड गिव यू द डाइजेस्टेड कोर मटेरियल. What's the point by impressing you with the peripheral material? And above all, again and again reminding you that language will matter. Language will matter. Language will matter. So we'll be using fairly good language across latitude, land, ocean differential, topographic surface variations, Coriolis deflection induced air motion, centrifugal force induced pressure variation. I will not use Chalu language. The language which I am using, you can straight away use this language in the exam. अच्छी language रखूंगा. I will use technical things only. Unnecessarily technical मुझे करने की जरूरत नहीं. I am again saying that we don't have to. But at the same time, if the books come with technical language, from day one I have been saying, geographical dictionary जरूर use करेंगे. Please use that. those terms will come, and with time you will understand most of the vocabulary I will be giving. Or vocabulary ka drama, the examiner is not doing much in climatology or oceanography. He's doing that more in geomorphology. But at the same time, climatology में कब वो ड्रामा शुरू कर दे, जैसे इस बार उन्होंने कहा टेम्परेट साइक्लोन का एक्सियल वेरिएशंस. So axial variation was just an English which has taken a challenge. So I would want you to keep that in mind. So अभी फिर से बता रहा हूँ यहाँ पर, every class you may be like frustrated by the fact that Sachin sir reminds me of the vocabulary and dictionary. Trust me, I am on your side. इसमें हीरो बनने का कोई फायदा नहीं है. Let us be humbled by the fact that dictionary has many words which will be associated with whatever we are reading. अगर मिलता है तो जरूर देखिएगा. ठीक है, प्लीज डू दैट. हॉरिजॉन्टल वेरिएशंस, तो पहला देखते अक्रॉस लैटिट्यूड्स. sun's insolation, solar insolations are not uniformly distributed. True or not? They're not uniformly distributed. As a result, thermal variations are seen across latitudes. Yes, heat excess and heat deficit. Have I already talked about it? The insolation curve. Yes, insolation curve, remember 30 degrees per. Did we talk about this? And did we also talk about the terrestrial radiation curve? ये मैं बना चुका हूँ आप लोगों के साथ. थोड़ा सा मैंने गड़बड़ किया इसमें, मुझे ऐसे रखना. True or not? The deficit zone and the excess zone. इससे क्या बनता है हमारा? ट्रॉपिकल, सब ट्रॉपिकल वर्सेस, या इक्वेटोरियल करते हैं ना सीधा. तो इक्वेटर पर क्या रहेगा? थर्मल लो. Air rises, no, is warm, rises due to convection. Low pressure created. Yes, एक पॉइंट और लिख दूं. Tropopause is raised. Remember, 18 kilometer tropopause is higher at equator. Tropopause is depressed. Did we see that tropopause is a slanting one? Equator पर high होता है, उस पर low होता है. Yes or no? So we're talking about surface. We're not talking about upper atmosphere. Tropopause is raised. Why? Because of rising air. Can I say sun's heat is the primary factor? And can I also write at surface inverse relation at surface, wherever the temperature is higher, the pressure is lower. Inverse relation between temperature and pressure when we have thermal pressure belts. Thermal pressure belts में होता है, बाकी में नहीं होता है. Mechanical pressure belts are different situations. Everyone okay? Sun's heat is the driver. Can I say that if you have understood this, can I write here equatorial low polar high? Do I need to explain that land will get heated up faster? So it will depend, it will create a low pressure. So heat will cause variations there also. Heat will cause variations there also. Yes or no? Surface variations, say for example, ice field versus black soil region. Yes or no? Ice field versus black soil region. Different albedo. Can I say different albedo and different absorption? So will the heating and the temperature change because of the thermal impact? Will it change or not? True. Topographic variation can be sun facing and sun facing slopes will heat more. The ones that don't face the sun, they will heat less. So will that cause a difference in the thermal part? And if the temperature changes, the pressure will change, and there is an inverse relationship between them. Are we clear? So two laws have been created, equatorial and polar latitude. Equatorial and polar latitude. Let's look at thermal के बाद mechanical pressure variations. They are not related to the thermal status of the surface. It's not warm air, a warm latitude, or cold latitude. They are due to the compression and expansion driven pressure variation. Okay. Non-thermal compression and expansion. Non-thermal compression and expansion. Get that? So generally we know that cold air shrinks. Yes or no? Cold air shrinks, warm air expands. Yes or no? Cold air shrinks, warm air expand. Let me take you to your school science. When you give temperature to the air, the molecules with temperature will start going apart. They'll go far away. So that means the air is expanding. And when you cool the air, the molecules come closer. Yes or no? And the air shrinks. Do you remember this? Air will shrink when it is cold and air will expand when it is warm. Is everyone okay? Yes or no? So ये यहाँ नहीं चलेगा. This is a thermal thing. यहाँ मैं क्या बोल रहा हूं? Non-thermal. So how will it expand non-thermally, compress non-thermally? Say for example, piston effect of sinking or subsiding air. Example, 30-degree latitude belt. Piston effect. Sir, ये piston effect क्या होता है? When the air is sinking, say for example, this has there were 100 molecules and I have a piston over here. School में पढ़ा था science में piston. If the piston 100 molecules are like this, if I take the piston down here, now what will happen? All those 100 molecules, will they be compressed more or not? Yes or no? Still 100 molecules. This is high pressure, this is low pressure. Is it because of temperature? No. Sinking air from top. सर ये कहां से आई वो भी बता देंगे. Sinking air from top, that will cause compression to happen. So that's called a piston effect. 30-degree latitude belt, high pressure. B is frontal upliftment. Example, 60-degree latitude, low pressure. Cold air, coming and colliding with warm air. Cold air coming and colliding with warm air. Both the air are fine, but because the cold air has collided with it, it causes the warm air to rise. Yes or no? This is rising. Is it rising because of temperature, everyone? Is it rising because of temperature? No, it is pushed up. Frontal upliftment. So what will it create? Rising air will create upliftment. Upliftment means low pressure. Here what will we have? Low pressure. So 60 degrees per. The air did not rise because air became warm. No. Air was forced to rise. Air was forced to rise. This is the cool air. This is cold air. Cool air collided with cold air and it was forced to rise. Mechanical lifting. Mechanical lifting of lighter air. Everyone okay with this? Is everyone okay with the first two? I'll also explain these or use these concepts when I'm making the air circulation. First, for writing, piston effect, sinking, subsiding air will push all the molecules, compress the molecules. And when the molecules are compressed, remember, more molecules in the given area, that makes what? High pressure. Frontal upliftment, the air was there but it was pushed up, ऊपर चली गई. So as a result, what was created? A low pressure vacuum was created. And then we have the centrifugal force. What is the centrifugal force? Let's look at this. So everyone, this is Earth. Earth is rotating west to east. Yes. This is our atmosphere. Because of rotation, will there be a tendency, everyone? Will there be a tendency for the gases to be pushed out? Yes or no? And will the force reduce or not as one goes away from equator? True or not? So will we have the atmosphere bulging here a bit? True or not? At equator, air is made to rise. Will there be a low pressure here? एयर को पुश कर रहा है ना बाहर की तरफ, एयर को पुश कर रहा है ऊपर की तरफ बिकॉज ऑफ द सेंट्रीफ्यूगल फोर्स. नॉन थर्मल की बात कर रहे हैं. एवरीथिंग दैट आई हैव टॉक्ड अबाउट इज नॉन थर्मल. Everything that I've talked about is non-thermal. If you have any questions, please ask. The causes of horizontal variations are thermal and dynamic. Dynamic causes are related to the rotation of Earth and the broad patterns of circulation. So what works as piston in atmosphere? The air itself, which is sinking. The air from the top, the cold heavy air from the top around 30 degrees acts as the piston in the atmosphere. I mean, if you remember subsidence inversion, remember at 30 degrees cold air just sinks. That acts as a piston. So उसके नीचे जितना भी atmosphere होगा वो क्या हो जाएगा? Compress हो जाएगा. Do we get that? Pressure gradient. So air moves from high pressure to low pressure. Air will always move from high pressure to low pressure, and that movement of air is called wind. And how strong will the wind be will depend upon the slope or the rate of change of pressure. The rate of change of pressure is called the barometric slope. If the pressure is changing very steeply from point A to point B, quickly the pressure has changed, so the slope will be like that. But if it is like this, point A is here, point B is here, that means a gentle slope, then the wind will be gentler. If the pressure changes very fast from point A to B, that is called a steep slope, steep gradient. If it is gentle, gentle will be like this, like my arm, steeper, 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 very steep pressure change. So that steepness is called the barometric slope. Air always flows from high pressure to low pressure. See, these are more molecules and these are less molecules. So moment I remove the separation, the more molecules will come and mix into the less ones. More molecules move into the less one. More molecules move into the less ones. So air always moves from high pressure to low pressure. And with the temperature we've already talked about, with altitude we have talked about, rotation also. I mentioned land and water difference. It has been found that if we have more humidity reduces the pressure, inverse relationship. So more humidity, so if we are talking of land and water at the same latitude, because oceans will be more humid, their pressure will be less relative to the land. So these are the four factors which you can write, but otherwise आपको explain करना हो, the first three factors are more than enough the way I have explained them. As a result, what do we get? We get equatorial low pressure, we get polar high pressure. These two are thermal belts. These two are thermal pressure belts. These two are thermal low. Thermal high. Now, you may say, sir, this is still warm area. How come we have high pressure? So this is not because of temperature. This is mechanical high, piston effect. And this one, subpolar low, is mechanical low because of frontal uplifting. We'll be talking about them tomorrow also, where we will connect these pressure variations and these pressure belts to winds. Is everyone okay with this? Pressure belts will be constituted through winds, and winds may we've already seen that high pressure is the zone of divergence, low pressure is the zone of convergence, and नीचे divergence होता है तो ऊपर convergence होता है, because अगर नीचे high pressure है तो ऊपर anticyclone हो जाएगा. This we have already looked at this in our previous in our discussion before this. ये कल होगा. Pressure belts, we'll be talking about them tomorrow. So this is what my intention of today's class was. कहाँ गया यार, ये तो बहुत देर ले रहा है. So everyone, I have a request. This is what I intended to do. What is atmospheric pressure? What are pressure belts? NCERT से अगर नहीं पढ़ा है तो एक बार फिर से पढ़ लो. NCERT का language तो होना चाहिए. We should be doing that. And I will be talking about higher ones. Tomorrow we'll shift from pressure and pressure belts. Tomorrow we'll have pressure belts and atmospheric circulation. Get that? I'll see you tomorrow. Keep your doubts and bring them there. And whatever weather report you're making, it is not just about collecting data. It is about seeing what is happening over there. So should continent also be affected in mechanical subtropical belt? Yes, Abhishek. These mechanical and thermal, they do not work in exclusivity. They can impact each other also. So a mechanical belt may be impacted because of its thermal variations also. So we'll see a combination of them also coming. अभी तो पहले तो दोनों को I have aligned both of them for you. One is a thermal, other is a mechanical. Tomorrow we'll see an interaction also between them. Yes. So thank you. Have a great day. Jai Hind.